Will poor database design lead to data anomalies in software development? Have you ever wondered how database design impacts the reliability of software? Today, we will tackle the question of whether poor database design can lead to data anomalies in software development. To start, poor database design can indeed lead to data anomalies, which are inconsistencies or errors that arise when inserting, updating, or deleting data. These anomalies can cause software to behave unpredictably, produce incorrect results, or even fail entirely. Let's break down the basics of database design. One key process is normalization. Normalization organizes data to minimize redundancy and dependency. This means structuring tables so that each piece of data is stored only once, with related data linked through relationships. If normalization is poorly executed, such as failing to separate data into appropriate tables, it can cause duplication and inconsistency. For instance, if customer information is repeated in multiple places, updating it in one location but not another can lead to conflicting data. This is a common source of anomalies during data operations. Data anomalies come in three main types. The first is the insertion anomaly, which occurs when it becomes difficult to add new data due to missing related data or an improper table structure. Next is the update anomaly, where changes to data must be made in multiple places, increasing the risk of inconsistency. Finally, there is the deletion anomaly, which refers to the unintended loss of data when deleting related records. Another factor to consider is the lack of constraints and keys, such as primary keys, foreign keys, and unique constraints. These elements help prevent invalid or duplicate data from entering the database. Without these safeguards, relationships between tables may break down, leading to data integrity issues and anomalies. Poor naming and documentation can also complicate matters. When developers struggle to understand the database schema, it increases the chance of misuse and errors that can cause anomalies. Additionally, ignoring scalability and growth can lead to performance problems and data management issues, indirectly contributing to anomalies as the system struggles to handle increasing data volume. From a practical backend development perspective, avoiding poor database design involves careful planning of the database schema to match business requirements. Applying normalization rules, ideally up to the third normal form, helps organize data logically. Defining primary keys for unique identification of records and foreign keys to enforce relationships is essential. Using constraints maintains data integrity, while documenting the schema and naming conventions clearly ensures consistency. Monitoring and optimizing queries and indexes is also important to maintain performance. Implementing robust backup and recovery systems protects against data loss. In summary, poor database design directly leads to data anomalies by allowing inconsistent, redundant, or invalid data to exist. This impacts software reliability, correctness, and maintainability. For backend developers, focusing on good database design principles is essential to building stable application programming interfaces, server-side logic, and data-driven applications that behave predictably and efficiently.